There it goes. All right, it's loud. That's fun. All right, let me get back to the problem. All right, so show me an answer. It doesn't have to be the right answer. Remember, this is how we roll, right? We're just going to figure this out. I'm going to move this over to the side so I can write some answers down over here. So boards up, please, and thank you. So we've got, I'm looking at the back there, D greater than E. Is that, oh, seriously? Is that CF?
Yeah.
Okay.
C,
F, B, A?
Yeah.
Okay. I just want to make sure that I'm saying it right. We've got D, E, C. Hold on a second. D. You have two E's in there. Is that on purpose?
No.
You want to? Go ahead and change that. That's okay.
Okay.
I was like, whoa. F. Okay. Okay. D. C. E and A are the same, we think, and F and B. And you guys have B, D, F. Well, that's a really pretty F. A. You don't have C in there. No commitment on C. I think I got you guys, right? Is that you? Yeah. Yep. What?
We changed.
Change your story. Okay, which one was you? The bottom? Wait.
Oh, wait.
That's this one. Gotcha. Okay. So you want to change it. Changing your story already. All right. E, A, oops, C, F, B. Oh, whoa. My stylus is really great today. Oh, I thought you guys had it.
We're not the smartest.
You are the smartest. You are fantastic. And we're just learning, right? So show me, you had the top one or the bottom one? Okay. So you want C equals, wait, hold it up because I didn't catch it. I don't have a super photographic memory there. C, E, F, B, A, D. Okay. Did I get everybody's answers the way they have them? And I think we've got all kinds of different answers, which is awesome because that means it gives us something to talk about. So I'm just kind of looking here at some common things. There's not a lot in common that we have. So let's start. Somebody start. Help me out. How did you get to the answer you got to? Hopefully it wasn't random. Hopefully there was something there. Go, Ben, get us started.
So I just kind of did all the formulas, and then I went from the largest number down to the smallest number.
Seems reasonable. That's kind of maybe what we all did, ish. So talk to me about how we did A.
So
You do A?
Yeah, it's negative. So
Okay.
I went, for a rectangle, isn't it base times height?
It is,
So I did 5 times 1.
Okay.
And so it was negative. That's negative 5.
Okay.
So that's why I have it in my last slot.
Okay, so you're going to say that the displacement is -5, whatevers. We're going to say that, can we all kind of agree that this is going to be in meters per second and this is going to be in seconds? Is that okay?
Yeah.
And just, again, so that we're all talking the same thing, are you calling this 1? Like each of those is 1 up?
Yeah.
Okay, so is everybody cool with that? Okay. How do we feel about that? Is that okay? What's that? That's okay.
Time was the bottom line, and then the arrow was positive.
Yeah. So it kind of looked like this one?
Yeah.
That's okay. No worries, right? We're learning and it's all good. So you can adjust if you need to. Is everybody okay with this being -5? That seems like a reasonable statement. Let's just look at which ones are positive and which ones are negative. Tell me about this one. Is it going to be a positive or a negative? Is the area under the curve positive or negative? Oh. Tell me the story. That would be an easier thing to do. What's the story that goes with B? Say that again. A car slowing down, right? So the car is going 25 miles an hour driving through a neighborhood and it sees a stoplight or a stop sign. So it's going fast and it's going to slow down. But as it slows down, it's still moving forward. You with me there? Okay, so this is a car slowing down just to make sure we're all good there. And what is the displacement that we have over those 5 seconds in this case? How would you do it? How do you find that the area under that curve, or the area between the line and the axis? How do you find the area of a triangle, guys? Go, yeah. Base times height divided by 2. So the base here is 5. Is that okay? The height is, looks like 1.5. That's kind of awkward. What's that? So 3 over 2 times 5 times 2. Oops, excuse me, times 1/2. Woo, that was almost a disaster there. Come on, stinker. There we go. All right, I like fractions. 3 times 5 is 15 over 4, 15 fourths. It's okay. Somebody's going to tell me what that is. Are we okay there? Is that all right? Tell me the story of C. Can somebody tell me the story of C? What does it mean to have a negative velocity? This is a big problem, you guys. Love this. It's going backwards. The speed is getting closer and closer and closer to what? You with me there? So what is that story really doing?
I think the start was here, the cars started here.
Is it moving? Is it?
Velocity, it's not a displacement.
Right, this is weird. This is a weird question.
How is that even real?
Oh, everything's real world, my friend.
That's it.
Well, we got to think about it. So what is this? This is something that's moving backwards, okay? Or moving, let's say, down. If we talk about up and down, we could do that, right?
But it's getting close to 0 meters per second.
That means it's doing what? It's going real. So let's talk about the speed. Can we talk about speed?
Yeah.
Speed doesn't have any negatives, right? So the speed is big, and then it gets closer and closer to 0. So it's slowing down. Is that okay? So this thing is slowing down, but it's moving backwards. So it's going really, really fast in the backwards direction. Okay? So if you're running a race, you could be running this way. But, I'm going to run this way instead, right? I'm going to go backwards, and then eventually I'm going to slow down. That would be an example. Okay? Or if you are driving in reverse, and you're going really fast, and then you hit the brake. You're slowing down. Does that make sense? You're slowing down while you're moving backwards. Is that okay?
I just don't understand why B would be positive and then C would be negative.
Okay, let's talk about it.
Because the graph makes it seem like that would be B would be negative, C would be positive.
Because you're looking at the slope, right?
Yeah.
Yeah. And this is why we do this. Because we have to get our brains around thinking about what the graph is showing. Okay? Because I've trained you in the last 3 days to always look at slopes, right? Yeah. But I'm going to go back here for just a second to that graph sheet if I can find it. Here it is. The only time you look at slopes is if you're going this way. Yeah. If you're going to the right. You with me there? So from displacement to velocity, or from velocity to acceleration. Then you look at the slope. When you go back, it doesn't matter what the slope is. Because the slope of a velocity versus time graph is going to tell you the acceleration. So, and we're going to get into these pluses and minuses in just a second, actually. So stay with me because I think that we're like on the cusp of it. This is one of those funny things in physics, you guys, where it's hard. We have to think about it. We have to kind of like monkey with it and like try to figure it out because it's not intuitive, but it's important. So here in this story, a car is moving forward. But as it's moving forward, its speed is going down. It's slowing down towards 0. Is that okay? This one is the same story. You got a car that's moving fast, and it's slowing down towards 0. but it's moving backwards fast. It's moving backwards fast. And as it moves back, it's slowing down. Okay? Does that kind of make sense? How you feeling, Jordan? You okay?
Yeah.
Yeah? So, what is the displacement in this case? It's kind of the same numbers, isn't it? You've got base times height, so it's going to be 5. I'm going to make that a negative 2.5, or 3/2, excuse me. Okay? Because it's starting in the downward direction. So we've got negative 3/2 times 5 times 1/2. The displacement here is negative 3.75. They have the same magnitude, but one is going in the positive direction and one is going in the negative direction. If I had if I had both of these objects, B and C, both of these robots, and I started them from the same place, right? It's kind of, do you guys remember, I don't know if you remember these little toy cars, the ones that you pulled back and then let go?
Yes.
Do you know what I'm talking about? Like, I feel like I used to get them in my Happy Meals, like way back in the day. But you like pull them back and then you let them go, and eventually they slow down, right? So if you pull one back and then, so I pull one back like this, and Isaac is going to pull one back like this, so they're at the same spot, and we let them go, this velocity versus time graph is going to be for the one that's going in the positive direction. This velocity versus time graph is going to be for the one that's going in the negative direction. Okay? They both have displacement. One's going negative, one's going positive. But their motion is the same. Is that okay? Okay. How about D? After all that B and C stuff, D should look pretty straightforward, yeah? Not quite at 1.5? Let's call it 1.5 just to make our lives easy. Is that okay? Because I don't think we have anything that's going to fight it. We're going to find the area, so that's just going to be 1.5 or 3/2 times 5. So 15/2. Or what's that, 7.5? Is it okay that it's positive in that case?
That's what I use.
Because it's moving positive the whole way? Take a look at E. Can you tell me the story for E?
It's 0. It's 0. It cancels out. Yes, it can. What she just said. So these are the same things with the magnitude, but then those cancel out. So why? Why would you ever do that? I don't get that. You're going backwards first, and then you go.
So I'm giving it some initial velocity.
Yes, and then it comes back
It
down.
slows down, comes back down. So this one would actually look like that, but it'd be the same problem. You with me there? Is that okay? That would look like this. We'll talk about why that's true in a couple days. But yeah, goes up, it has velocity, it slows down, and then it comes back down. Yeah. The area here and the area here are equal. This one is negative. This one is positive. The displacement that this object is going to see is what? 0. 0. That's a big deal. Woo! And then F is not very exciting again after all that. What's the displacement on F? 1/2 times the base, which is 5 times, what, 1? So 5/2, which is 2.5. Okay, put them in order for me. Help me out. What goes first? D is greater than, B is greater than, F. Awesome. Comes next. C or E. And then, oh my gosh, why is this being so goofy? C and then A. That's okay. Did you all learn something? Okay. That's all I care about. If you're not invested in anything, then you're not going to pay attention to me talking about this. Do you see what I'm doing? Like, this is the secret of the teaching, right? Yeah. By making you kind of think it through first, you consider these pictures a little bit, right? That's what I'm doing. Now that you know the secret, you still have to play along though, okay? Okay. How are we doing? Are we okay? Okay? So far, so good? All right. I want to do a little chart to kind of think through what we just kind of started talking about, and we're going to do some conceptual questions related to it. So here comes the chart. You need to write this down in your notes. We're going to kind of talk it through. Whew. Oh, no, we have to do homework. Oh, let's do our homework first so we don't forget, because I will forget otherwise. Almost forgot. Didn't I put that in? Nope, I didn't. Hold on just a second. Please wait. Oh my gosh, I can't find it. Ah!
This card one.
What?
For like a real world application for graphene on the last thing. You're standing upside down. You threw a ball towards the ground and came back up.
Sure.
That's what it looks like, right?
Oh yeah, we can just do basketball, right? Oh duh. I'll take it. You got it? Oh yeah, I didn't even think about that. Brilliant. All right, I'm just gonna put it up here because I can't find it on my thing. I thought I had it up here, but I didn't. So sad. How did your homework go? Was it great? Was it confusing? Where were you at?
I forgot the triangle thing.
Oh, do you want like 2 minutes to talk to your neighbors about your answers? Do that. 2 minutes to talk to your neighbors about your answers. Go.